How does a GPS navigation receiver work? Have you ever wondered how your GPS navigation receiver knows exactly where you are on Earth? It's a fascinating process that combines satellite technology with clever mathematics. Let's break it down step by step. A GPS navigation receiver determines its location by picking up signals from multiple global positioning system satellites that orbit our planet. Each of these satellites is continuously sending out radio signals. These signals contain a unique pseudorandom code, the exact time the signal was sent, and the satellite's current position in space. When your receiver is turned on, it listens for these signals. It measures how long it takes for each signal to travel from the satellite to the receiver. Since these signals travel at the speed of light, the receiver can convert this travel time into a distance measurement. This process is known as trilateration. To accurately find its three-dimensional location, which includes latitude, longitude, and altitude, the receiver needs signals from at least 4 satellites. 3 satellites provide the intersection point in space, while the 4th satellite helps correct any timing errors in the receiver's internal clock. The receiver generates its own pseudorandom code and compares it with the code received from each satellite. This comparison helps determine the exact time the signal arrived. The difference in time between when the signal was sent and when it was received is used to calculate the distance to each satellite, known as a pseudorange. With the pseudoranges from 4 or more satellites and the known positions of these satellites, the receiver can solve navigation equations. This allows it to compute its precise position relative to the center of the Earth. Once the receiver has calculated its position in Earth-centered Cartesian coordinates, it converts these coordinates into geographic coordinates that we can understand, such as latitude, longitude, and height. The height is often adjusted to relate to the geoid, which approximates mean sea level. This location information can then be displayed on maps, used for navigation, or integrated into vehicle guidance systems. In summary, a GPS navigation receiver works by receiving synchronized signals from multiple satellites, measuring the time delay of each signal to calculate the distance, using trilateration to determine its three-dimensional position, correcting 4 clock errors, and converting the calculated position into user-friendly geographic coordinates. This entire process relies on precise satellite orbits, accurate atomic clocks onboard the satellites, and sophisticated algorithms within the receiver to provide real-time location and timing information anywhere on or near the Earth's surface.